Good morning, everyone. I'm Andrew Lawson, the manager of the analytics team at Ravenpack, and together with my colleague Grinis from the data science team, we'll be doing a presentation today that concentrates a little more on the infrastructure and data side of what we do. Although, as always, this is very tied in with Common Lisp, and I will be touching on that in quite a few places. Those of you who've seen previous presentations from myself or other people from the company in previous years will probably be expecting me to talk about the classification system and things like that. I'm not going to repeat here. You can go back and look at previous presentations that are online. Today, I'll be talking about some other stuff. So the first half of this talk will be myself, and then Ina later. So Ravenpack, as a company, has been producing news analytics since 2009, although the company has been around for a few years longer. And initially, the idea, or our clients, were financial institutions. And that's still mostly true. The initial idea was to produce information useful to financial institutions, which means mostly financial news. But since then, we've slowly added news providers, one by one, and these days we cover quite a wide range of information. Everything from, as I said, financial news, which means things like company reports, sackings, hirings, CEOs, board changes, assorted other stuff to do with shares, etc. But now we cover general news as well, things like elections, wars, terrorist attacks, bad weather of various types, anything that could conceivably impact our clients' investments, and or in the case of some of them, things like risk calculations. As I say, we receive news from multiple providers, which means dealing with many problems associated with it. I'll go into that in a minute. And in particular, all of the data extraction and processing code is written in Common Lisp. So although today I won't actually be reading any code, I will be talking about the infrastructure around the Common Lisp part of the system. I'll also mention, though, that some parts of the input and output of the system are written in Java and Python for various reasons, but by far the biggest part of the system is Common Lisp. I'll quickly mention classification, as I said, but I'm not going to concentrate on it today. And the mostly Lispy infrastructure, but at a higher level view. And then over to Ina, who will talk about our data in depth. Classification. To pass over this quickly. Our system is mostly a rules-based system. First of all, because it started that way, but secondly, because customers appreciate the advantage it gives, because often when we provide data that may be wrong or misunderstood, it allows us to debug very easily what's happening in the system. Something that ML, for example, as an approach, does not allow easily. When we get news stories, we're finding mentions of entities, it's like companies, organizations, people, places, positions, sporting teams, currencies, and there's more. And we're finding events that include or mention those entities, war, famine, lots of financial stuff, as I said. So the outputs of our system are things like a certain company has done a certain thing at a certain time with another company, or some such stuff. We also provide sentiment data of various types and information about things like how long ago was the most recent story connected with the same company. We do have an ML team. We recently started building an ML team, and they are building on top of our current infrastructure. But as I said, we have to be extremely careful given our client expectations. And I will be mentioning the size of the pre-built images later on, but the main reason they're so big is because of the millions of entities we actually have to carry in memory. You'll see why I mention that later. So we're receiving news in various formats from multiple providers, 15 formats and counting at the moment. And when I say formats, various of them are XML or similar, but they're different XML. So even if in those cases we still need separate parsers. And the worst, or the most problematic, according to our collection team, is in fact a government institution, which will surprise nobody. And we're also dealing with an incoming stream of about 200 million stories per year and rising. Rising mainly because we both add new providers yearly and because the providers we have are continually adding to their sources of information as well. Also, the side effect of this is that the documents and the complexity of the documents that we're receiving is also increasing as providers add new and interesting stuff. But we do add the providers based on their utility or to our customers. So every time we add a new provider, we're obviously studying what they will give to the products. So to get around all this, and obviously we can't have our classification system just understanding 15 different formats, our collection team converts all of the incoming stories into a standard format. This diagram here says XML format A and B, correct, and some 1970s binary format, also correct, unfortunately. Although things are getting better. This Ravenpack internal format allows us to concentrate on the content and not how it's presented. Now, a few of the problems we have here when it comes to actually classifying these documents once they've been converted to a standardized format. Tables, for example, you might imagine are fairly easy after all. It's just rows and columns. Unfortunately, rows and columns are never that easy. We have to make automated educated guesses because we get tables that have missing rows, missing columns, empty rows, empty columns, headers that don't line up with the data, rows that vary in various ways, things like this. So we have quite a bit of code that attempts to guess what data belongs to what column or row and things like this. So we're very much at the mercy of the people that write this stuff. My second point here, that journalists can write. True, that makes our parsing of English easier. Good writers make for easy extraction of data. Bloggers can't. Also a problem. We have a lot of very bad English. Lawyers and accountants can write but can't format, and this is where the table problems come in, because many of the sort of standardized forms and stuff like that go through government agencies and we end up receiving are basically just dumps from Word documents and the like, and where the formatting is horrific. I'll mention also that as we branch out from mainstream news, the actual formatting of the document becomes more important to its understanding. We are dealing more with tables. We have to deal with things like sections, chapters, lists, footnotes, tables, etc. And not only be able to understand them, but also relate them to the rest of the document. For example, sentiment in a short story might depend on where an entity is mentioned in the story. Sentiment in a large document with multiple chapters probably doesn't vary so much depending on the position, because each chapter may actually be about a different entity. So how do we deal with all of this data? Well, we like AWS and use a lot of Amazon services. But storing so much data separately in something like S3, which is sort of a distributed hash table, is expensive. They basically charge you for the puts and the gets. And so putting every single story or every single set of results or intermediate results into S3 is a major cost problem. So we actually now have a storage service with an API which abstracts this away. As with the diagram, we have our applications, Lisp applications, are calling the storage service to get access to or upload information. And behind the scenes, there may be S3, there may be other places where this information is stored. And the main way of saving money here is to store in chunks, because we almost always, I say almost always, deal with data by provider and by date. We can store compressed chunks of stories, 100,000 stories per chunk, in files by date, by provider, this sort of thing. And as long as that is effectively our index, that works great. Obviously, it does not give us a way to search over other pieces of information. But for us, thankfully, our needs are very predictable, and this saves a lot of money. Ordering. This is one of our main challenges. We guarantee that we deliver analytics about stories in the same order as the incoming stories are received. This is a requirement from our clients that's been around a long time. It's a strict one and not one that we can easily break. But for those of you that deal with parallelization, in particular parallel processing of streams, you'll probably know what the problem is here, in that your multiple worker nodes will not necessarily run at the same speed, depending on many and varied reasons. But the output of such stuff has to be reordered so that the order is the same as the incoming stories in our case. And this complicates things quite a bit, although we do have a good running solution at the moment. Of course, it can't affect too much the actual speed of the classification system. And a single instance of our classification application cannot handle the load. This is not because the code itself is particularly inefficient. It's more a case simply that we're doing so much work on any particular story that no matter how big a machine we throw at it, it just can't handle the load. So we have a parallel system. We have our incoming stories. We have a distributor application written in Lisp, which is sending out stories to individual workers, which do the work, return the results to the distributor, which deals with any ordering problems before sending it off to another system which deals with delivery to our customers. All of this actually works extremely well, and the architecture we have now scales linearly up to the point which we've tested. And I expect it to continue to do so in the near and medium future. A couple of choices we made when we implement this actually turned out to be rather useful. The workers themselves don't register themselves with the distributor application. Rather, they simply send requests for work. So the distributor has absolutely no idea how many workers exist other than counting the number of different ones that contact it at any particular time. Also, the workers, as we're using internal queues between the different components inside a worker, and those queues are set up to be length limited. They cannot go above a certain number of stories. This effectively means that if a worker has too many stories, it will halt its requests for more stories. So they're self-limiting in that sense. A worker will never ask for more work than it can handle. Our distributor actually also uses queues in this way in order that our entire system works neatly in lockstep, and there'll be back pressure at any point if there's any sort of overload. Of course, that sort of thing leaves lots of opportunities for tuning, and we have done so. And there are issues whereby, for example, one large document sent off to one worker might take quite a while to come back, and therefore, as you might imagine, although the results of everything else behind it have also already returned to the distributor has to wait for the large document results to come back before it can send on the properly ordered set of data. There's a lot of slack in the system that's designed to let things continue to operate even if there's a wait point. But given that our incoming data comes in large peaks and troughs, the performance of the system goes up and down and tries to cope as best it can, and it does. And for those interested, we're using ZMQ3 and Rucksack to handle transmission and reception of story and result data, and we find this works very reliably indeed. Although we do have to be incredibly careful with Rucksack in particular that things like results coming back cannot hold references. to other objects in the system, because obviously those references would be broken by Rucksack, and attempting to deserialize later, things just don't add up. We've had some problems like this, and this means that our results have to be very clean and very simple. So having these workers be independent has the other side, a handy side effect, that we can cycle workers in and out to follow load. So these workers are individual EC2 machines with a Lisp image running on them. Starts up reasonably quickly, a couple of minutes, and so if necessary we can follow load just by adding in and removing workers. The distributor has to know nothing about this. Of course, the distributor being a single point of failure, you might say, if we want to swap a new version in or anything like that, we have to do some routing magic, effectively swapping the routing to a different machine. And all of this requires us using pre-built images, and this has been a huge win for us. It was, up until very recently, we just started everything from source and let it run. It didn't matter too much. It might have taken 15 minutes to start an application because it had to load a lot of data. But it didn't interfere too much. Now that we have a distributed system that has to cope with hugely varying workload, we've moved to using images in the newer version of the product. And particularly because the amount of data we have to load into images has grown hugely in the last couple of years, a start from source can take an hour or more, and therefore starting for an image, even if it takes 2 or 3 minutes, mostly time to bring it into memory, is a huge win for us. You can see roughly what resident memory looked like, or effectively an image size looked like over the years. So back in 2010, a gig was fine. 2015 until recently, 3, maybe a little more. And 2021, with the most recent stuff we're working on, we're looking at 25 gig images. Which brings its own issues with things like garbage collection, which I'm not going to go into today, but we've done a lot of tuning there. And of course, simply the size of these images means that uploads and downloads are slow. Restarts are slow only because they have to read from disk and get stuff into memory, and that can take more than a minute. However, there's some tricks we're doing here to make everything a bit easier. Our workers and distributor apps share about 95% of the data in memory. Although the distributor just distributes stuff, it also has to do some checks on entities and requires it having all of the entity information that the workers also have. So we actually have a thing I'm working on right now, which is that the same image can be either application. It contains all of the information and all of the code for both applications. And simply by calling with the image with different startup arcs, it will actually start a different application. And the really useful side effect of this is guaranteed compatibility. Over the years, I suppose anyone else who's done transmission between images of some sort of serialized data, if you change, for example, the number of slots in a structure, it will just explode when you deserialize it elsewhere. By having one image build each day and used for all of the parts of the system here, you can guarantee that all of the definitions match. And another thing, which I'm moving towards right now, is if multiple apps share in-memory data, then you can create a pre-built image which only contains that data, and then following image builds can each use that as the base image for the builds. This will remind a lot of people of Docker to a certain extent. The whole point here, of course, is to both make builds quicker, because the pre-built image is loading, again, about 95% of the data that needs to be loaded to build an image. And so the builds of the apps themselves are a matter of minutes. Other stuff we're doing. Built images contain configuration for all relevant apps and deployment scenarios. So this is a side effect of some work I did a few years ago on updating our configuration system. It effectively means that we have one config file for every site and every status. neatly sectioned off. And so our built images load the entire file, but don't apply any configuration until the application is started. And this means that you can start the application in different sites with different command line arguments, and it will start up with different configuration, which may be things like what databases to use, where the other apps are, IP addresses, some minor configuration differences and all that. So it's all runtime. Our configuration, the app that we're running, is all chosen at runtime, not compile time. So this means that our image is completely self-contained code, data, and configuration. So we can ship them everywhere, and we don't even have to have some sort of configuration file on the machines we're using. The only thing, the machine where it's running has to know the arguments to start it with, nothing else. Delivery. How do we deliver data to our customers? Well, this is actually quite a simple part of the system. Customers who want up-to-date data that is in real time as things happen can just subscribe to an HTTP stream of JSON data, but they can provide filters in the query, filtering by things like the entities they want to see, what events they want to see, and there's some other options as well. This means that customers don't have to see the entire stream, which, as you might imagine, is quite heavy these days, if they don't want to. And for those who are doing historical studies, looking at data from the past, as most of our clients will do, both when evaluating our product and then doing studies, continuous studies, as many do, to work out how best to use the data, then we now have a web interface that they can go to do queries and download data chunks, the results of those queries, and that allows even more filtering than our real-time stream. And also has the ability to create widgets and dashboards, so a client who's interested to just watch what's actually happening out there in the world can create their own customized dashboards, widgets, etc. I'll just show you a screenshot of this app right now. As always, given the time we live in, I can't do a presentation without mentioning the coronavirus. So here's a demo dashboard available to our customers that this is a screenshot from a couple of days ago showing how things are happening in the coronavirus world. And interestingly, last year we actually did a coronavirus dashboard for public consumption, which is still available to anyone who wants to see it. You can find it at coronavirus.ravenpack.com. It looks like this. It's basically a sort of neatened and more beautiful version of the previous page. You can all go and have a look, see what you think. This is all based, as I said, on the data we provide and some other stuff that we're getting from elsewhere, as mentioned down the bottom. So that's my part of the talk, just to give you some background on where our data comes from, how it's processed, some of the tricks we're now using to process data at very large amounts of data. So I'll now pass you over to Ina from Data Science, who's going to give a little talk on how our data is actually used, which is something we've not presented before. And I must, as always, meanwhile, mention that we are hiring. Common Lisp, of course. The team continues to grow. But we also have positions open for Python, Java, data science, and assorted other stuff. So anyone who's interested, go to our website and you'll find all the information there. So thank you very much, everyone, and I'll now pass you over to Ina.
Thank you, Andrew, and thanks a lot to the organizers for the opportunity to speak today. My name is Ina Grinis, and I work in the data science team. We sit a bit like an internal client within the organization, as our mandate is to turn our data into valuable insights. I'm specialized in macro strategy, which includes global macro investment strategies and macroeconomics. And so today I want to show a couple of examples of how our data can be leveraged in the macro space. At Ravenpack, we have built algorithms to identify over 300,000 different events, including companies, organizations, countries, products, etc. We have also created almost 7,000 different event categories that span business, economy, societal, etc. topics. These algorithms are able to identify not only the specific event, but also the direction. For instance, whether economic growth is going up or down. We can also identify whether an event is a fact, for instance, a data release, or if it's a forecast or an opinion. Or we can also identify the importance of the mention of the event within the news article, and much more. If a specific event does not exist, you can always create your own bespoke narrative by using our keyword search functionality that allows you to search for a single keyword or a combination of keywords in either the headline or the body of millions of news articles. Once you have defined your macro narrative, you can either use the news volume, or we also have sentiment scores, and you can also use our connections conventions functionality to capture the strength of relationships between different entities in a dynamic fashion and build network graphs to identify important trends, monitor competitive landscapes, underlying risk exposures, and summarize relevant connections that may otherwise go unnoticed. So let's start with news volume. One thing that economists and macro investors are particularly interested in is understanding the relationship between economic data and financial markets. The first chart on this slide contrasts the rolling S&P 500 returns, so US equities, with GDP economic growth nowcast from the New York Fed model. At any point in time, the New York Fed model, which is the blue line here, gives us a prediction of the current quarter real GDP growth based on 37 widely tracked US economic indicators such as ISM indices, industrial production, unemployment, etc. This is from the official website where the New York Fed update their model on a weekly basis, incorporating the latest data releases. As you can see, the markets have been widely leading economic data. In particular, the New York Fed turned into negative territory only in April last year, way after it was obvious that activity had collapsed because of the pandemic and markets had already played that. And there is nothing we can really do about this because most standard economic data is backward-looking and released with significant lags and often revised. Of course, markets anticipate economic data releases, and therefore what should really matter are not releases per se, but surprises relative to expectations. This is why on the right figure here, we look at an index of economic surprises. A positive reading in the red line means that economic releases have on balance been beating expectations. Unfortunately, as you can see, there have recently been significant disconnects between economics data surprises and markets reaction, with markets sometimes not caring about significant surprises or even interpreting them in the opposite way. For instance, taking a bad labor report as sign that there will be more fiscal stimulus ahead and therefore a better growth outlook. This type of different interpretation of economic releases, sharp changes in economic outlook expectations that have not yet appeared in the data or consensus expectations, and even the pure fact of a certain release being more or less discussed, all these will appear in the macro market commentary, and that's why news is where you have to go to be able to create high frequency indicators that capture all this in real time. And here on this slide, this is what I'm trying to do. I have leveraged the Revenpack taxonomy to create two macro narratives. One that captures the US growth outlook improving, and the other one that captures the US growth outlook worsening. Here are some examples of event texts that appear in each of the narratives, and the figures plot the rolling weekly news volume or inverted for the growth worse narrative. As you can see, the growth worse narrative started gaining substantial momentum already from early March last year. And throughout last year, the different waves of growth better and worse narratives coincided with reopenings, lockdowns, progress on vaccines, etc. Most recently, the huge green wave here is based on the US fiscal stimulus passing and upgrades in the economic outlook for several institutions, including the Fed, IMF, etc. As you can see, the markets have been tracking these narratives pretty closely, And so this is a great and simple example to illustrate why it is so important for macro investors today to go beyond standard economic data, such as traditional macroeconomic indicators and economic expectations. Another key narrative right now is reinfections. We don't have a reinfections event in our taxonomy, so this is also a great way to illustrate how clients can leverage our keyword search functionality to create bespoke themes and track them. So for instance, here, what we are trying to do is to use this keyword search to look for keywords in headlines. And we use words like reinfection, reinfect. Without quotes, we also capture words that have the same root. So for instance, reinfections, reinfected. With the quotes, we have capture exact expressions. We can do as involved topics as we want. We can use negations to, for instance, get rid of expressions that we don't want, because there are a number of articles that could be about why, kind of explanatory articles that look at why do some test positive after vaccination. So we can get rid of them by using negations. Once we have done this, we can also look at reinfections by vaccine. And for that, we can basically add any combination of entities among the over 300,000 that we track. And here, because we want to look at vaccines, so we can add the vaccine name and also the institutions, companies that have been producing them. And we can also decide on how relevant we want the entity to be. So basically, where in the news article the entity has to be identified. And the higher the number, the higher up. Once we have done this, we can also use a wide range of functions to quickly generate analytics on the samples of news we have selected. And this is actually a great way to illustrate how someone could leverage our data currently without doing any coding at all. So here, for instance, we look at the unique news count, also the buzz, which is an indicator of compared to previous look back window, how big the volume is currently about the specific topics that we have defined. And then we can quickly go and generate dashboards that keep us abreast of the latest newsfeed of our bespoke topics of narratives. And we can even click on news and see the text and understand why certain things are being appeared and keep this as an alert and a dashboard that we follow on a regular basis. Now, I also want to give an example about how people have been leveraging sentiment. So as you know, Ravenbank has developed proprietary algorithms which assign an event sentiment score ranging between -1 and 1 to each event identified. And here in this example, we are trying to leverage the sentiment to create a leading indicator of monetary policy. So we look at all the events that are mentioned with the Fed, the US Federal Reserve Bank. And it happens that over 2/3 of events are actually about interest rates. So for instance, interest rates guidance up, interest rates down, etc. And in our taxonomy, the events that capture increases in interest rates receive a negative sentiment score, because this is considered as negative for the economy, because if the central bank starts increasing interest rates, this is going to hamper growth, and this is why this receives a negative sentiment score. However, if you look here, you can just look at the average inverted ESS to create a leading indicator of monetary policy. And the intuition is very simple. It's because the narrative of interest rates going up starts appearing in the news and people start discussing it way before the central bank actually goes and increases interest rates in practice. And this same approach actually happens to work also in emerging markets. So again, using the narrative around the central bank, we are able to create a leading indicator of monetary policy and where interest rates are going to go next. And finally, I want to also illustrate the connections functionality. So one very important macro topic right now is reflation. reflation is the expectation of inflation rising as the economy, stimulated by monetary and fiscal policies, pulls towards full employment and growth. And investors care a lot about this because they want to understand which asset classes they need to invest in order to preserve the value of their portfolios. So here we are trying to assess the sensitivity of gold and Bitcoin to this reflation narrative by looking at whether gold or Bitcoin is being more or less mentioned in news articles about reflation. And you can see here that, for instance, in the 2016-2017 Trump-related reflation trade, or even last summer when gold hit above 2000, it was really gold that was very sensitive to this reflation narrative. Whereas more recently, you see that Bitcoin, called sometimes the new digital gold, is starting to creep up as the reflation hedge. You can also use the convention to generate network graphs that allow you to capture the strength of relationships between different entities in a more dynamic fashion. And this can be used to express trade ideas in more interesting ways or better understand the underlying risk exposures. So for instance, here on the left, we have a network graph that looks at the strength of relations of companies with cocoa. The nodes and the edges are weighted by the number of conventions with cocoa in 2020. Downstream, for instance, you recognize the famous chocolate manufacturers like Hotel Chocolat, Nestlé, etc. The standard way of looking at relationships between companies and commodities would be to look at, say, correlations of stock returns with cocoa returns or some fundamental data. However, this assumes that the historical relationships that held in the past are going to also hold in the future, which might not be the case because markets are very dynamic. You may even lack the data if it's a new company, or the company might be starting to enter a new business, so the past data is not really relevant. And in any case, the company can also be more or less associated with a certain commodity for non-fundamental reasons. You probably have heard a lot people talk about markets fundamentals disconnects. Well, in some sense, news adds a layer of interpretation to this more fundamental data, and you might want to capture that because it can help you understand disconnects between price actions and fundamentals. Here on the right, we have the network of conventions of cocoa with places. Upstream, we have cocoa producing countries. Downstream, we have the countries that rely on cocoa to manufacture confectionery. And this, for instance, can be used for someone who is trading cocoa as a commodity and wants to systematically monitor supply chain risks like natural disasters, war conflicts, etc. in the upstream countries, or things like consumer spending and confidence indicators in the downstream countries. And finally, I want to end with a geopolitics example. One very important geopolitical risk over the past several years has been Trump-related trade wars with China. And clients have been super interested in understanding which companies and sectors would be more or less affected and become the potential next targets for the imposition of tariffs. One way of extracting such information is to look at news that mention the US and China and the curated trade war topic. And this is what we have been doing in this simple video, and then look at how these exposures are changing over time. This approach can be generalized and scaled to any topic and can be used to produce interesting dashboards and alerts that help you stay abreast of particular risks that play out and can impact portfolios. So just to finish off with a quick summary of why news analytics are really a super interesting data set in the macro space. Well, first of all, you have a real-time coverage. You could see that we were able to produce high-frequency real-time indicators with this economic growth example, for instance, where you saw that the advantage of news over more standard economic data and economist expectations. We have a global coverage. We saw an example of where an approach of creating a leading indicator for monetary policy for the US also worked in an emerging market like Malaysia. We have a great variety of topics. I mean, you saw we had examples of reflation, of geopolitical risks, reinfection rates, any type of topics. And this is a very important point because a lot of times clients come to us and they don't really know whether they should go and buy credit card transactions data or online job postings, etc. Well, news allows anyone to kind of like have an open taxonomy, because news covers everything. And so if there is one data set that you can basically use in order to address any topic, it's news. And then finally, deep historical archives. This is something that is extremely important to investors, because if you want to backtest investment strategies or understand how the predictions of your models have been behaving in the past, you really need deep archives in order to be able to do that. And our data goes back to 2000, so that includes several very important episodes like the Great Recession and etc. So this is also super important. So finally, our team, the data science team, we do a lot of research on our data, but we also have a lot of external organizations, both academics and practitioners, who have done a lot of research. And so you can basically read a lot more and leverage this. Thank you so much, and look forward to your questions.